So over here now, part C. Question is, what's the velocity and direction at time equals 0.5 seconds? Okay, the velocity, you might say the v final. Now it's not v final x or v final y, it's the v final. That is, it's a combination of the x and y components. You might say it's like the magnitude of the vector. And the direction as well, so I'll just put the arrow over it. So the whole vector, magnitude and direction of velocity at time equals 0.5 seconds. Okay, how would we do this? Well, we need to be able to combine our Vx final and our Vy final. Alright, well, what's our Vx final? Our V final in the x position. I'm sorry, in the x direction. Well, if you recall, back from when we were talking about how projectile motion works, there's no change in the velocity at all in the x direction. So the v final in the x direction is exactly the same as in the initial. 1.3 meters per second. Nothing's accelerating it, so it's not going to speed up or slow down. We do, however, have to find the final velocity in the y direction. Alright, so VFY, how would we find that? Well, if we use our equation where it is, I'll write it over here. I'll write it in black actually so it stands out. If you recall that V final equals V initial plus acceleration times time, and this could be for any direction. Let's apply it then to our y direction and see if we have what it takes to solve for V final in the y direction. Do we have a V initial? V initial in the y direction? Yeah, we do. It happens to be 0, but that's convenient. Okay, plus acceleration in the y direction? Yeah, we have acceleration, and we have a time as well. So V final in the y direction goes 0 plus negative 9.81 times time, 0.5 seconds. And that gives us a V final velocity, or a velocity final in the v direction. That should be 5.1. Oh, no, that's not right. I'm looking at the wrong thing here. Negative 4.905 meters per second. Sorry, again, my mouse is, or my pen tablet is being kind of picky right here. It's kind of jumpy. Now I'm boxing these off, but these aren't the complete answer. This is just the x component and the y component of the velocity as this at t equals 0.5 seconds. So what do we do to resolve these into the full vector of v final? Well, we use the Pythagorean theorem. V final equals what? Well, that's the initial, I'm sorry, not the initial, that's the final of the x component squared. So it's 1.3 squared plus the final of the y component squared, negative 4.905 squared. So this will give us the full value of the velocity at 0.5 seconds. So V final is what? This is what I misspoke before. This should be 5.1 meters per second. 5.1 meters per second. Okay, it's not in the x, not in the y, but it's a combination of both. It's at an angle. And by the way, what angle is it? What's the direction? We can do that because theta equals the inverse tangent of the y over the x. That's negative 4.905 over the x over 1.3. Inverse tangent of that, what do we get? That's 84 degrees. All right, so at 1/2 second, the ball is falling at 84 degrees to the horizontal. But what direction? Well, it's downwards. You could say the y direction is negative and the x direction is positive. And that would give us south of east. South of east. So you might say below the positive x-axis. But that's our direction. That's our magnitude, 5.1 meters per second for the final velocity. And that's our example 4.3, parts A, B, and C. I hope that helped, and I'll look for you on example 4.4, which is actually 5.4. Okay, I'll see you then.